going to continue our lesson on solving absolute value inequalities. So yesterday we talked about the basics of solving absolute value inequalities, how we need to determine whether we have an and statement or an or statement. And sometimes we won't know whether we have an and or statement until after we finish simplifying a little bit, because your inequality symbol might flip. In a regular inequality symbol, if you divide by a negative number, so here's a little example, negative 5x is greater than 25. I divide by negative 5 on both sides. When I divide by a negative in an inequality, it flips the inequality symbol. So it flipped from greater than to less than. So I end up with x is less than negative 5. So the same thing happens in an absolute value inequality. So here I have a little example. Negative 3 times the absolute value of x minus 2 is less than or equal to negative 9. So the way it is right now with less than or equal to, it looks like an and statement. However, when we divide by the negative 3 on both sides, that eliminates the negative 3, so we're left with absolute value of x minus 2, but when we divided by that negative 3, the less than or equal to symbol flipped to a greater than or equal to symbol, so we get the absolute value of x minus 2 is greater than 3. So it's really an or statement. So you have to be careful. Do you have an and statement or do you have an or statement? If you don't have a negative being multiplied, you don't have to flip your inequality. But if you do have a negative, then you need to make sure you flip your inequality. Be very careful with that. So let's move on to our examples. Okay, so here we have negative 5 times the absolute value of 2x minus 3 plus 15 is greater than or equal to negative 10 for our first example. Notice that our absolute value is not isolated, so I need to get rid of the plus 15 and the negative 5. Reverse order of operations tells us to get rid of the 15 first. So we're going to subtract 15 on both sides, eliminating the 15, and we get negative 5 times the absolute value of 2x minus 3 is greater than or equal to negative 25. Now I need to divide by negative 5, so I'm going to divide both sides by negative 5. That's going to reduce the negative 5, and I get the absolute value of 2x minus 3 is less than or equal to positive 5. My inequality flipped. So now I can do my two inequalities to solve, and instead of an or statement, I have an and statement. So I'm going to write 2x minus 3 is less than or equal to 5, and 2x minus 3 is greater than or equal to negative 5. Notice we write the first one exactly as is. The other one we flip the inequality and we change the sign. So now we're going to add 3 to both sides to solve. And we get 2x is less than or equal to 8. Divide by 2. And we get x is less than or equal to 4. On the other side, we're going to solve again. So we're going to add 3 to both sides. And we get 2x is greater than or equal to negative 5 plus 3 is negative 2. We're going to divide by 2 on both sides, eliminating the 2. We're going to get x is greater than or equal to negative 1. So my two critical values are 4 and negative 1. So now that we have x is less than or equal to 4, and this is an and statement, and x is greater than or equal to negative 1, we can draw our number line. So we're going to draw our number line here. On the left, we have negative infinity. On the right, we have infinity. Somewhere in the middle is 0. Now positive 4 is going to be to the right of 0. Negative 1 is going to be somewhere to the left of 0. This is x is less than or equal to 4. The or equal to part is this line underneath the inequality. I have less than, and then I have or equal to. That equal to means that 4 is closed. So at 4, we're going to bubble in a closed circle. On the other one, x is greater than or equal to -1. The or equal means -1 is closed. So we're going to bubble in a closed circle. Now this is an and statement. When you have an and statement, you shade in between the two values. So now we can write our solution in interval notation. We're starting at -1 and it's closed. Since it's closed, we use a bracket and we're starting at -1, comma, we shade until we get to 4. So our second value is 4. We're closed at 4, so we use a bracket. And that is our first example. So for our second example, we have -7 times the absolute value of 3x minus 6 plus 21 is less than -42. Once again, our absolute value is not isolated, so we need to isolate it. We're going to subtract 21 from both sides, eliminating the 21. We get -7 times the absolute value of 3x minus 6 is less than -63. And now we divide by -7 on both sides, reducing the -7. So we get the absolute value of 3x minus 6. And since we divided by a negative, my inequality flips to a greater than. -63 divided by -7 is +9. And now my absolute value is isolated. This is greater than, so this is an or statement. So we're going to write 3x minus 6 is greater than 9, or 3x minus 6 is less than -9. And then we solve. So we're going to add 6 to both sides here, eliminating the 6. We get 3x is greater than 15. We're going to divide by 3, and we get x is greater than 5. On the other side, we're going to add 6 to both sides, eliminating the 6. We get 3x is less than -9 plus 6 is -3. Then we divide by 3, reducing the 3, and we get x is less than -1. And remember, this is an or statement. Now that we have our two values, we can draw our number line. On one side we have -infinity. On the other side we have +infinity. 0 is somewhere in the middle. +5 is to the right of 0. -1 is to the left of 0. And this time we don't have the or equal to part. It's just greater than and less than. So my points, -1 and 5, are open. So we're going to put an open circle on both of these. And this is an or statement. So that means we're going to shade on the outside. So we're going to shade this way, and we're going to shade this way. And now we're going to write this in interval notation. We start shading at -infinity. So I'm going to put a parentheses because infinity always has parentheses. And then we're going to put -infinity, comma, it shades until we get to -1. -1 is open. Since it's open, we use a parentheses. Then we have a break. This blank area represents a union. So I'm going to put a U for union. And then I start again at 5. 5 is open, so we're going to use a parentheses and start at 5. Comma, we shade until we get to infinity. and then we close it with a parentheses because infinity always has parentheses. And this is our solution to example 2. Well, I hope you enjoyed today's lesson where we continue talking about solving absolute value inequalities. If you have any questions about this topic, I know there's a lot of information. Go ahead and send me a message in Schoology, or you can send me a text and I'll try to help you out. Have a great day.